Let's now talk about cluster and workload CI/CD pipelines. What we're going for in this section here is to explore a little bit the use of idempotent declarative methods over imperative methods. By that I mean, instead of writing a sequence of commands that will execute, let's say, for the creation of the cluster, we're looking into tools like the ARM templates, Azure CLI, Terraform, or Ansible. Those could be easily saved into a GitHub repo. So you have a private repo and you save all of that configuration, and you can easily recreate that cluster later on. You can also version between the various releases of your infrastructure. So when we look at infrastructure as code and we do it in this method, we now have ways to go back in time and see what changes were made, but also easily replicate an entire environment to a different region, for instance. In our use case, we're going to be using GitHub Actions for this. You can certainly achieve the same thing by using Azure Pipelines or Jenkins. The final result is something that we can essentially cookie cutter. We want to have our AKS services and cluster following all of the guidelines and parameters that we've agreed upon with all the businesses, and then have that being easily replicated. If we expand on this picture a little bit, the way we're looking into this is as follows. You have a user. That user, let's say, will commit some YAML changes to a GitHub repo, a private GitHub repo. Those changes will then be applied to the cluster. So the user really doesn't have direct access. He can't really run kube control commands directly against the cluster. So the user would first, I'm just going to change this here. So user would go first and do something like a git push into this private repo. And to achieve this connection between what the user pushes into GitHub and what the cluster then absorbs and takes into a new state, we're going to use a little agent here called Flux. So what Flux will give us is the ability to detect new configuration changes in our GitHub repo. You can filter down by a branch, for instance, and then trigger deployments or update to a desired running configuration based on those changes. What we have with that is an easy way to keep the state of a cluster. If we were, for instance, to spin up a second cluster in a different region, we could use the same method here, pointing back to that GitHub repo and then retrieving all the policies and configuring the cluster in a way that we know it is desirable for our workload. With this approach, with Flux and GitOps, we can certainly achieve a lot of the desired operational state in a very short amount of time.